Yes, yes.
Okay.
Ready.
All right. Thank you. Okay. Assalamualaikum and a very good afternoon, ladies and gentlemen. I would like to thank everybody for still keeping this topic on toast as we've reached the third day, the final day of the webinar on IR 4.0 for water subsectors. So I'm Nur Hayati. I'm still emceeing for the webinar today. I would like to do some housekeeping notes before we start. May I encourage everyone to please kindly switch off your mobile phone to silent mode or switch off the device that is nearby from the device where you're streaming for Zoom, because we can hear some echo, and then we would like to have a smooth Zoom session in a minute. Please kindly keep yourself to mute. I think that is like the standard sentence that we have in every webinar and in every conference. Please unmute yourself or please keep yourself mute. So for the moment, we would like to advise everyone to please kindly keep yourself on mute. And then you can switch on your video if you find the session is smooth on your side. I would also advise for you to switch off your video to provide more bandwidth for the speakers later on. So ladies and gentlemen, today we have 3 more speakers for the session. And then we have our 2 speakers ready, Mr. Matthias Kremer, hi, good morning, and Mr. Michael Weiner, good morning. A very good morning to our colleagues in German from German Water Partnership. A very good afternoon to my colleagues here in Malaysia, streaming from Malaysia. And I would like to thank everybody from Academy Science Malaysia, the Malaysian Water Association, for joining in today. So without further ado, ladies and gentlemen, I shall begin the session with our first 2 distinguished speakers, Mr. Matthias Kremer on digital sensors for water and wastewater technology, and he is head of global industry management from Jumo GmbH and Company KG. His co-speaker today is Mr. Michael Weiner, also on digital sensors for water and wastewater technology, and he is the product manager automation products from the same company. Ladies and gentlemen, without further ado, the floor is yours. Thank you.
Yeah, good morning, or better say good afternoon to Malaysia. Good morning to German participants. I want to welcome our 3rd colleague, Mr. Victor Wong. He's in the audience. I saw him. He's our Malaysian colleague. Yeah, let's start my little presentation. We have 2 parts. My part is the beginning of the sensor part, and Mr. Wiener shows you afterwards cloud and SCADA solution from Jumo for the sensor data management in digital water treatment. So I hopefully can start my screen now. Okay. Can you see the full screen now?
Yes, it looks great. Perfect.
Okay.
Thank you.
Let's start. Yeah, again, warm welcome from Jumo. Thank you for your time with us. Our presentation, the name is Digital Sensors for Water and Wastewater Treatment. And of course, we are talking not about just about the sensors, we're talking about automation solution, sensor data up to the cloud, and what is possible with these cloud solutions. At first, have a little look on the world of Jumo. Jumo is a family-owned business in Germany. In the middle, our senior boss, Mr. Bernhard Juchheim, and in the left side, Mr. Michael Juchheim, he's the son. And on the right side, Dimitrios Chasiadis, who's our CEO. We are 100% family-owned, and our business is producing sensors and automation products for different kind of industries. And one of our main industries is the water and wastewater sector. So we are doing making machines or plants. We are doing components for the measurement and control in water plants. So our tasks, our things are temperature sensors, liquid analysis, pressure level, flow, humidity. And on the automation side, you will see some products later in applications, monitoring, control, recording, and automation. Yeah, the company was founded in 1948 in Fulda, in the middle of Europe, in the middle of Germany, not far from Hamburg, from Frankfurt Airport, maybe 90 kilometers. From this, we have spread it out in the world in the last years, 14 production sites and 25 UMO subsidiaries worldwide. And we are working with more than 60 agencies in other countries. We have 2,400 employees and a turnover of 250 billion euros. So what we say in Germany or in Europe, we say we are a big family company, family-owned company. Here's our team in Malaysia. We are 3 engineers. Mr. Wong is part of the audience today. He's the middle guy and his colleagues left and right. So we're doing servicing and they are your partners if you have questions to products or solutions in Malaysia. Our focused industries in Malaysian market at the moment are the glove and rubber industry, which is famous in Malaysia, I think. Yeah, here we are in the chemical processes. We are in wastewater and water applications and all kind of other industrial solutions like thermal processes and whatever you or wherever you need sensors and control units. Coming to the presentation of the digital or to the digital part, what is the digitized water treatment? Yeah. Yesterday, we have fabulous things heard from Siemens and other companies about augmented reality, artificial intelligence, digital twins, and all these fantastic things. Today, we are going back to the bottom of the things, to the real world, to sensors, because nothing is you don't have virtual reality if you don't have a real sensor in the end or in the beginning. It all starts with the real sensors. We're living in a beautiful world, more or less, and all things and all processes are analog in the world. So why should be everything digital in future? Looking in the history, we have the industrial revolutions in the 18th century, the mechanization, followed by the electrification of the world, the automation, and today we are talking about digitalization, industry 4.0, and they are from water and wastewater 4.0. Let's have a look on the analog sensors for the waste and wastewater market and the water market. So from you can have liquid analysis, which means pH redox electrodes, conductivity measurements, oxygen, chlorines, and other disinfectants. Of course, for the water industry, necessary level measurement, flow, and pressure, and sensors for temperature. All these sensors are in the beginning analog. All our sensors you can use in all water qualities you can imagine, from ultra pure water for pharmacy and biotechnology, water for injection, over cooling water, cooling tower water, pool and spa installations, processed water, aquaculture, up to municipal wastewater, and in special cases, dosing and control of conduits. These analog values, now we want to connect to the digital world. Our world is digital. Everyone has a mobile phone. Everyone has a digital, maybe TV at home, and has Wi-Fi and all this stuff. And so we must connect our analog sensors to the digital world. So we need sensors with a common digital interface. Today's solutions are like this. We have a couple of digital sensors, We call it DigiLine. This is all sensors for the liquid analyzers from pH to conductivity to oxygen, which can be digitally connected with a bus system, with a connector box to a central unit. With this unit, you can handle 6 digital sensors, or with a bigger Varitron system, you can handle up to 62 digital connected sensors. And from these central units, you can go to SCADA and cloud solution. When should we use digital sensors instead of the standard analog sensors? Is it positive to use it in all kind of projects? So maybe you know single measurement points. Here you see a turbidity measurement and a water channel in a river control. You know maybe skid controls to prepare water for technical processes to desalt water, or you have a wide area installation like a fish farm or a wastewater plant. Yes, of course, for all these installations, digital sensors has advantages. This is the simple installation, the plug and play more or less. We have a very secure data transmission. We have the transmission of additional sensor data like lifetime, calibration, logbooks, min-max values, and so on. We can have remote access to the sensor if it is digitalized. And yeah, and we can doing a networking between sensors and actuators, pumps and valves if necessary. This is the advantage of the digitalization of these analog sensors. An example given here, this is a cooling tower, a typical industrial cooling tower. It's liquid filled, and this water of the liquid of the cooling tower is controlled by our Aquis Touch with a couple of sensors. Yeah. Typical values in the cooling tower, the water of the cooling tower is the conductivity, sometimes pH, turbidity, flow, level, temperature, and ORP potential. Normally you have such a plate where it's all installed, the water line and the electrical parts, compact system. You have short distances to the instrument and a local control of valves and pumps like here. Okay, with this instrument you can go to SCADA or cloud solutions by Profibus or Ethernet and LAN. This is standard. But sometimes you have more than one installation point, and the digital sensor networks allows now to connect multiple towers, more than one tower to one central instrument. So we remove the Aquis Touch, setting a passive small connection box, and then we go with one digital master wire. We can go from cooling tower to cooling tower and can connect a lot of installations to one central automation solution, the Varitron 500, which Mr. Wiener will show you later a little bit more detailed. You have maybe one central unit where HMI, where you can check all the values, where you can handle the system. You have a connections up to the Wi-Fi and cloud solutions. And of course, you have remote access via iPhone or via phone, sorry, via mobile phone or iPad or pad to all data to each single sensor. So this is today's solution. Yeah, we have the analog sensor, for example, given here some pH electrodes with a digital interface to a connection box with one digital wire to our central unit. And from this, we go to Ethernet. This is today's solution, typical. And the future is in the sensor market that the sensor will have the full Ethernet functionality with standardized interfaces and connectors. We have cables, data, and power connection on the data and the wires. It can be a 4 or 2 wire Ethernet connection. And this sensor we call IIoT ready, Internet of Things ready. These sensors are the future, the next generation. So we can go with our analog values with a digital little interface inside the sensors. We can go directly to the Ethernet, and from the Ethernet we can use all cloud services. Here, blue, recording, engineering, asset management, control, and other things, which will Mr. Wiener show you later. So this is the future here we are working on, and this is the next step to make it more easier, to make it more digital in the sensor market. Yeah, this was my first part. Questions we are doing on the end of both parts after the presentation of Mr. Wiener. And yeah, let's look what Mr. Wiener can tell you or give you in additional information. I will stop my presentation now and wait for Mr. Wiener.
Yes. So I hope you see the right screen. Matthias?
Yes, we can see.
Okay.
Yeah.
Okay, perfect. Then, yeah, thank you very much for the powerful beginning to Mr. Kramer. And also hello from my side here in Germany. My name is Michael Wiener. And yeah, we are pleased to present a very interesting topic to you today. We have chosen the topic well monitoring with a PLC to cloud solution. Yeah, and I can guarantee you that is a very innovative and modern issue. And yes, then I don't even want to waste any more time with the introduction. I think let's get started. Yeah, on the first slide, I would like to introduce our level concept to you. For this, we start with the first level. This is the sensor level. And here I would like to introduce the different sensor sizes that Tumor has in its portfolio for this solution. And there we have the liquid analyzers and level. And yeah, so we come to the second level of the solution. Here we talk about the automation level. And here I would like to introduce our new PLC system. I think Mr. Kramer already mentioned our Varitron 500. And the Varitron 500 is the central unit of the automation system. And I can tell you this much, it is a really great product and a powerful PLC, but I will show you. And finally, we have I/O modules, which can be seen here. And with these different input and output modules, you have numerous options for solving a wide range of automation tasks. Yeah, finally, we see here the third level of our model, and this is the cloud level. Here you can already see from the logo that we would like to introduce the Tumor Cloud to you today. Yeah, and there we are very proud. But now, in more detail, I will now start with the applications around the Tumor Varitron 500, or better called the software applications. Yeah, here in this graphic, you can see the different software applications of the Tumor Varitron 500. And here we start with our Tumor Smartware Setup Varitron. This is an offline configuration tool. Then we have the Codesys version 3.5 integrated here as a development environment for our PLC. Then the Node-RED as a graphical development environment. Maybe the one or other already knows this environment. I think it's very nice. And last but not least, the Tumor Web Cockpit. And this is an online configuration tool via a web server. Okay, I think this much about the different tools. If you want more information, please let us know. But now I think we want to put the focus on our solution. Yeah, that's also our next topic block, but don't worry, this will not be a mathematics lesson. It looks a little bit complicated and could cause problems, but we don't want to talk about problems today. And here we want to talk about solutions. And I think, yeah, let's have a look to the Tumor system solutions. The first applications are the centralized ones here that I want to show you. And here we can see the PLC and IOs. So the input-output modules are located on a central DIN rail. In addition, we can connect a web panel for the on-site visualization or our Digiline sensors that Mr. Kramer already mentioned via a serial interface. If no panel is required on site, I think it's also a topic of costs. It is also possible to carry out the visualization in the browser with the web visualization from CodeSys. And that's also integrated in our PLC system. Yeah, this brings me to our most famous application, which I would like to show you today. This is the connection to our Tumor cloud. And we are, yeah, particularly proud of this application. Yes, how do you set up the connection to the Tumor cloud? To do this, go to the Tumor web cockpit. This was the online configuration tool, which I have already presented to you. Then click on the icon Tumor cloud. And here you can set up your connection in just a few steps. Yeah, I think it's quite easy. And when everything has worked, you can start right away by doing configurations or something like this in the Tumor cloud. And now we want to go a little bit more into detail. Yeah, therefore I have an application example which should clarify the benefit of the solution. Here you can see a well monitoring with a pumping station. And important in this application is the water quality and the water level. And the entire measurement and control technology here that you can see is provided by Tumor with our automation system, with the pH measurement and the level measurement. And with the cloud, we are able to monitor the current status of all pumping stations around the world. And the communication to the cloud is encrypted. Here we use the messaging protocol MQTT. Also, the worldwide client access via the browser is coded. Here we are using HTTPS. And via a previously configured dashboard, it is now possible to monitor all stations and their values, as we can see here on the bottom. Yeah, this is a big advantage, I think, for decision-making processes. The communication to the cloud requires an internet connection. This can be done by cable. I think that's a standard way, or by a gateway, for example. Yeah, our SCADA system is designed on the same basis as the Tumor cloud. And the main differences are that the Tumor cloud stores all data in its own data center and keeps it secure. With the SCADA solution, the customer has to take care of the server, the installation process, and the availability, and also backup himself. Yeah, the Tumor cloud application is available worldwide via the internet. The SCADA solution is only available on the intranet, so inside the company network. Yeah, in this market, the cloud, it is common to establish a subscription. So, and by the SCADA system, on the other hand, we provide a license file with the software for a one-time price. But I think that's very common for a SCADA system. Okay, then on the next slides, I will present the most important features and benefits you get by using the Tumor Cloud. Yeah, now a short outlook to give you a better impression. On the left side, you can see how map services can be integrated with specific information about locations. In the lower area, you can see actual values and evaluations as an example. And on the right side, you can also integrate cameras. In the lower area here, you can see an event list with the possibility to receive incoming alarms. But that's only a dashboard. You can create it as you want. That's only an example. Yeah, then here are two examples where we have visualized process pictures. And sorry, here we don't have something specific for the water industry so far, but I think you can imagine this. Yeah, you can say it's a white piece of paper and you create it with these applications that you have or that you need. Yeah, on the left, we have a building monitoring. On the right, a complete shark silo process that is animated. Yeah, and here it is possible to see actual values and also to control specific process steps and to look at the result through the animation. Yeah, then the reports. Yeah, on this slide, you can see a daily report and the corresponding history. And the information can be sent as an email, for example, and the charts are stored over a long time. So, yeah. And on the right side here, we have two examples how reports could look like. But here we have many options. So also here, if you need more information, then please let us know. Yeah, with our solution, we provide a very powerful alarm system. So shown on the top left, the possibility to plan availabilities. At the bottom right, you can set up alert cascades according to the availability. And here you have the possibility to use 4 alarming signals in a row. So starting with email, SMS, push notifications, or a voice call. So, and if an alarm is incoming above right, it can be received. Yeah, and here you can see our responsive design. It's also part of the solution. On the right, for example, it's shown as an iPhone X, but it's only a showcase. So you can also use a tablet or Android phone. So it will shown in a responsive design. Yeah, so we reach the last slide here. My wish is that you simply register and test our solution. In the lower area, you have the link to get to the Tumor Cloud. And here you can take a look at our demo applications. And as you can see here, we have also a demo for the water industry. Okay, then this was my last slide. So thank you very much. And yeah, if there are any questions, then please let us know. For part 1, it's Mr. Kramer, and for part 2, it's mine. Thank you.
Thank you. Thank you so much, Mr. Kramer and Mr. Wiener, for very nice presentation on the cloud system. May I encourage our audience, our participants, to kindly note your questions in the chat box, or you're most welcome to switch on your video and unmute yourself to ask the questions directly to the speakers today. Ladies and gentlemen, we have a couple of participants also streaming on Facebook and YouTube Live. So thank you so much for joining us this afternoon. Any questions thus far?
All happy with our mission. All happy.
All very happy. Meanwhile, we have inserted a survey in the chat box. For all participants attending via Zoom today, to please kindly fill up the survey, and at the end of the session, we shall have some very short discussion and presentation on the results of the survey by the Malaysian Water Association. So may I know the cloud system, Mr. Kramer, Mr. Wiener, the cloud system is usable for any kind of devices, and is it now open to public usage in German?
We have special protocols, and if a device supports these protocols, in our case, it's for example OPC UA. Then it can be connected to the Tumor cloud. But how will I say? That's only the view for the Tumor cloud. If you want to use the SCADA system, then we have many more options. So, for example, other protocols like Modbus TCP or Profinet or Profibus. So there we have much more options. But for the cloud solutions, at the moment, it's OPC UA.
Okay.
And our system Varitron and the cloud and all these things, they are open for all sensors, not just for Tumor system. Yeah. All sensors with standard signals and standard protocols can be connected. So we have an open system. Yeah.
Okay. May I know, in relation to yesterday's presentation, also, how is it that the government governs the integration between the clouds that each companies have and providing for the water and wastewater companies in Germany? Because obviously you are not working in silos, so all the data is some sort of integrated. How do the government manage that integration?
In Germany, it's a little bit differentiated in comparison with the USA. There we have the Cloud Act, for example. In Germany, we don't have something like this. So it's our data center, and it's the government don't have to do anything with our data. So it's, if you would host your data in our cloud, it's your data.
I see.
Our government has no opportunity to take a look in these data, and I think that's is correct. So,
which means that the data is exclusively protected by Jumo yourself. I mean, by the company itself. It's not accessible for the government, except for those who have subscribed and also using the services. If I'm correct.
And the Jumo data is stored in Germany in a German center,
right?
Not Amazon or other countries.
Okay. Because Mr. Kramer mentioned that this is actually a family business, and then it is like a very hub-bound between those involved in the establishment of Jumo itself. So I'm just wondering, Okay. Okay, so we have a question here from Ms. Larika. What do the speakers see as the biggest challenge for companies in Malaysia on their way to being fully digitalized? And how can you help us overcome that?
Maybe we can ask Mr. Victor Wong. He's our representative, our technician guy in Malaysia. Maybe he has better ideas than me.
Mr. Wong?
Maybe Mr. Wong can activate his microphone, can answer.
Yes. Mr. Wong,
hello, everybody.
if you're...
Yeah, can you hear me?
Yeah.
Yes, we can hear you.
Perfect.
Yes.
Okay, hello, everybody. This is Victor Wong from Tumor, Malaysia. We are a small team here. I'm very sorry, I didn't really get the question posted just now.
Okay. The question is on what is our biggest challenge for companies in Malaysia on our way to being fully digitalized? How might we overcome this?
Well, I think it's a very broad questions and has multiple ways of. It's quite subjective, actually. I think we had to break down to what kind of level, or maybe baby steps, what kind of achievement that you want as a company or a group. Because I think there are a lot of organizations here. Everybody will have a different goal. Yeah, I'm open for discussion, for further discussion. We can talk more in depth to help you guys out, like to achieve like what you really want to do. Yeah.
Can I chip in a bit on the question asked just now?
Sure, Datuk.
We are just developing similar to what we can do. Of course, we cannot pair with what the experience in Germany. But my question is what is the obstacle or barriers when you start off this journey towards Water 4.0? And that's on the context of Germany's German side experience. And if looking at the Malaysian context, what is your advice for us to have a quantum leap to have this done on a fast track basis? What are the main components or criteria that is required to realize this journey, to cut short this journey shorter? Because we have about 20 years to do this, but if we can cut short, it will be better. But we need to know what is the main components that can make this thing happen.
Ooh, that's a big question. Not easily answered.
Okay.
It's the same in Germany. We are not starting not all companies and authorities starting in the same digital level. Yeah, we are very different level in Germany and Europe too. We have the same problem. So not all companies can work with augmented reality, with artificial intelligence tomorrow. So some of our waterworks, they are very in an analog position today. They working very analog and with handbooks, write notebooks by hand, writing data by hand, doing measurements by hand. So we are not. It's not always rocket science in Germany. So we have the same problem. So there's different levels of automation everywhere, like you in your country, and yeah, it depends on where you start from. If you're starting with the basic measurements in a waterwork, that you do pH measurement by hand, the next step should be do it automatically. Yeah, install some automatic measurements, and these automatic measurements should be able to have, or should have, digital interfaces for the next step, maybe for a cloud installation. So step by step, depending on from where you are coming. Yeah.
Okay, understand.
But first, you must have you must look on each side and on each interested company, which level it is. So,
yeah, I guess a simpler question would be asked in any projects is about the dollars and cents. How much has Germany spent till today to develop this Water 4.0 in all aspects? A rough figure?
Oh, I can't answer this question. Sorry.
Is it in millions or in billions over the few years that we have developed to put where you are now? I don't know. My question also quite related to what is the status of Germany now? Are you have you reached 4.0? Are you still at 3.5 or 3.8, something like that?
Yeah, I think Germany is something between 1.0 and 4.0.
Oh.
It's different. It's different. Yeah, it's very different. It's very different.
Yeah, it depends on which sector we are talking about. By talking in average, because sharing with you what we have in mind is to look at overall water cycle in the water sector, from the rivers right up to the supply, and then it will be recycled back. So there will be a lot of sectors involved. One is the rivers authority or all the river stakeholders. Then we talk about the water supply stakeholders, and then talk about the circular economy. So all this would have to be broken down. If you look at our water operators, we have 13 water operators in the peninsula, and each of them will have different level. Maybe some have no facilities at all, meaning that zero, not even 0.1. So we are doing that kind of exercise now to identify who is what and try to narrow down the gap so that everyone will be at par before we start the journey. So maybe that's one of the steps. That's why I'm trying to get some lesson learned, so that we don't have to start from ground zero. We just take the data from the Germany experience and just move on, especially on the challenges. What you feel in terms of, maybe you go to simple thing of law, how the data sharing is going to be shared. Will there be any what you call high level data that cannot be shared? That also involve this cyber security and the acceptance of the public and the investment from all the various companies. And will that be a mandatory or it's just a voluntary? Because it's a mandatory, of course, you are very firm and you may have some resistance, but at the end of the day, you get result. If talk about voluntary, you may drag the thing because it's based on affordability and the return. So at the end of the day, I still feel that there must be a special fund to do this, especially on the networking in terms of this internet accessible to the remote areas especially. So these are the things that we have in mind of the challenges that we may face, but we have to study what the experience that you have in Germany, so that you can take that on board, so it will not be off our list when we do the detailed study on this. That's just a thought. If we have, maybe we can get in touch with you separately to get other advice, and maybe we can look at how Germany's companies can assist us in one way or the other.
Yeah, example given, we have in Germany for our cloud solution, I think in the moment we have two nice projects with Waterworks. Yeah, before they collected the data on a electrical recorder. Yeah, and now they used the cloud solution, because our cloud solution is Michael, maybe you help me. They have a security level, yeah. And this is one of the main things they are looking on in Germany. Yeah, you know that all waterworks are critical in infrastructures, which we must be secure against attacks from viruses and other things. And so they have a very extreme look on the data security in this case. Maybe. But there's, in the first step, I know from a lot of conferences I met that the infrastructure companies are very slow. They're slow with these new solutions, yeah, because they're afraid of attacks, from cyber attacks.
Okay, thank you for the explanation. We will get in touch separately, I guess, because the topic is quite wide.
It's a big theme that we can talk hours with.
Yes, understand. This is very interesting subject matter, so we need to discuss separately.
Michael, you have some additional information? Or?
Yeah, I can confirm that we are certified in this direction. In Germany, we have some standards, I think, as Matthias said. Now, the interesting question would be what's the situation in Malaysia, and if there's also a standard that we have to challenge to use such a cloud solution. Yeah.
Thank you, Mr. Kramer, Mr. Weiner, and Datuk Kadir. Any other question from the floor? There's no question from Facebook. Anyone else would like to further discuss on this topic?
If not, you are invited to contact us or Mr. Wong in Malaysia directly. We are open for discussion later and for deeper discussions.
Yeah. I have to say, on behalf of Malaysia, this subject matter is fairly new. It happens to us when we presented to the committee. It's either minimum question or no question at all, because this is a very new field. So let the Malaysian side gather their thoughts, and we will get in touch with you individually.
Yeah.
Welcome.
Thank you, Mr. Kramer and Mr. Weiner, for such kind presentation and excellent sharing on the technology brought over by UMO.
Thank you for inviting us, and
thank you so much.
bye-bye.
Thank you.
Okay. So, ladies and gentlemen, while waiting for the next session, I would like to encourage everyone to please kindly have a look on your chat box, because we have prepared some questions there. And then I shall give you a little bit of time for you to please kindly answer the survey questions before we move on to the next speaker. So please kindly have a look at the chat box over Zoom. And then you can find a survey on benchmarking criteria for IR 4.0 for water sectors. It's on Google document. It's very easy for you to answer. And then our secretariat will gather the number of participants that have answered, and also we will have a look at the results later on before we end the session today. Thank you. So probably in about 5 minutes. So I'll just let everyone do the survey. For our Malaysian participants, sila duduk, jangan lari. Please try and answer the survey questions that our team has prepared for you. Thank you. By the way, it's only 2 pages. It's not much. But I'll just let everyone enjoy the music for a little more while. So I'm just checking how many responses that we already have now thus far. So basically the survey has questions on impact and benefits of digitalization in water utilities. There's only a couple of questions really, and then what should technology digital providers do better? Very, very brief questions, only 2 pages. If you have problems accessing the survey questions, you can tell us in the chat box. So we need at least some good numbers for us to have a nice graphical presentation at the end of the session. I do feel like I am in a like a radio station or something at the moment in this webinar. So the number is increasing. Thank you so much for those who have answered our survey. It's very, very short. It's only 2 pages. Will not take much time. And we also have our 3rd speaker ready for today. We have Dr. Hamid Bashetti later on from Bolerai GmbH. The link is provided in the chat box for those of you who cannot access it. Oh, okay. Thank you for the increasing number in participants taking the survey. Please keep going. Just briefly checking with my team how many have responded before we continue with the next session. Okay, good number. We need a couple more responses, please. As I'm going to start the next session with our final speaker for the day. Thank you, everybody. Thank you, ladies and gentlemen, for taking part in our small survey for today. We thought we do the survey online and live so that we would have responses from the participants over Zoom today. So appreciate your kind participation very much. Okay, I would like to bid our heartiest welcome to Dr. Hamid Beheshti, Product Manager, Automation Products.
Hello.
Hello, Dr. Hamid. Dr.
Yeah.
Hamid Beheshti. Hi.
Yeah.
Our warmest welcome to Dr. Hamid Beheshti, and his topic is on comprehensive remote monitoring practice for sustainability of decentralized water solutions. Dr. Beheshti is the co-founder and CEO of Boreal Light GmbH. Without further ado, ladies and gentlemen, let us welcome Dr. Beheshti. The floor is yours.
My pleasure. Thank you so much. Good evening to you. Good morning to the colleagues in Germany. Actually, talking with Malaysia is always full of memories for me. I stayed a semester in Malaysia, in Kuala Lumpur, right in Pantai Panorama compound, close to the university. So it's just reminding me a lot of experiences there and a lot of good memories. So then let's officially start. I share my screen with you then here. Let me just fix the screen, and then actually my work would be more, my presentation would be more related to the use scenarios and applications in need of comprehensive remote monitoring and comprehensive digitalization of the water industry. My work is mainly focusing on the way that we are using these technologies to bring sustainability and to bring security to water project in the most remote part of the planet. To know that it's good to, oh, not just it's good, it's necessary to get into exactly what we are doing. When we know what we are doing, then you understand why such a technology is necessary for such a project. So the company Boreal Light GmbH is based in Berlin, and what we are making and what we are providing here is the basis of the access to hygiene drinking water. And then our project is called Water Kiosk. The Water Kiosk as a project created by Boreal Light in different countries, different continents in the world, is in charge of delivering hygiene drinking water to communities. But which communities are we speaking about? We are talking about this type of communities that their problem is access to hygiene drinking water. Please bear with me a few slides. I need to explain what we are doing so you understand the link between the topic. So in these communities, the challenge is that, the challenge is this green canister and the bucket that you see here. So the green canister and the bucket that you see here are the ones that we are the ones that the local communities are struggling with the access to quality and affordable water. So this type of water is neither safe nor always available. So it's repeatedly faces with unavailability of the resources. And imagine the cost is, for this quality of water, the cost is $10 for 1 cubic meter. In the dry season, it goes higher. And the problem again is not just the drinking. We are also struggling with the same water problem for farming. So not just the drinking, also farming. The part that is irrigated here, you see the accumulation of salt, and the part that was not irrigated, you see the vegetations there. I just try to make a bit of connection between this and the topic we just talked. We are talking about sensors here, the sensors that read what kind of water is going where. Otherwise, something like this happens. Accumulation of salt happens and kills a farm. Then when in the same scenario, just bring you a bit of sense about the reason we are into the very field is the cost of water. The cost of hygiene drinking water in a market like East Africa that we are very much engaged is for this quality of water. this quality of water that is called hygiene drinking water, we have it for $4 for 20 liter. $4 for 20 liter of hygiene drinking water, $200 for 1,000 liter. Imagine we are talking about a community that the cost of water there, the salary of a normal person in many of this remote area, if you pay a person $80, $90, you can hire him, her for a full month and they would be also satisfied. Then imagine for the quality water, the cost is $200 per month. So these are the different costs of the hygiene drinking bottles. You see the average is $4. So a solution to tackle this challenge was a simple, affordable solar water desalination system that can work in a remote part of the world. What does it mean remote? Remote means either there is no electricity, there is no access to the place easily. They can be islands at the middle of the ocean. They can be villages in the middle of nowhere. So the access is a challenge. The access of sending people, access of having a person at the site, a technician at the site to carefully monitor what is happening there, what is going on there. So that's why the system is fully running on solar, nothing else. There is no diesel, there is no grid, nothing. The system, even there is no battery bank. The system is running directly on sun radiation and powering the machine. And then the simplicity. So simplicity is another nature of our work, making locals able to run the machine. It's not a good solution if you let the locals run the machine and at the meantime you leave them without any access to any technology at the backbone, at the support of those services they may need. Just a quick visualization here. This is our workshop in Berlin. So this is the way that the machines often look like during the production, and the cost of water production from this technology is just $50 per cubic meter. Just compare it with the other prices, and then slowly I'm getting into the topic of remote monitoring then, and the detailed remote monitoring for such applications. So we decided, when we are producing water such cheap, why not selling water? When we are selling machine, so we are selling machine and that's okay, it's running, it's a good business, but let's be in those remote area. Let's be ourselves in the field. Let's be ourselves checking what is happening there during the operation of the machine. So we started selling water from our machine. That's why the business is called Water Kiosk. In the village communities, we started selling water at 10 cents, $10 cent, and in urban communities for $1. So in the urban, 1/4, in the villages, 1/40th of the average market price of the same quality of water. So then we had to go to places, most of them the remotest of the remote part of the planet. We had to have our eyes. We have to have our eyes over the system. So from one hand, we are telling that the machines, 80% of the operation, 80% of the maintenance, everything of the machine needs just a wrench and a screwdriver. And from the other hand, when we see where we are, even although a wrench and a screwdriver is enough for the operation of the machine, but still, you need to know what is going under. The issue is not always the maintenance. Many times, you need to know what is going under to be able to support, to be able to train, to be able to update the machine. So this is the places that we are. Our stronghold is in East Africa. Now in your side, we are in East Asia. In East Asia, we're in Indonesia and the Philippines. So Central South America and almost the entire part of Africa, we have our records. So look at the faces of our operators. They are simple people. They are young people, teenagers. These two, Zaytun was 16, Akram was 17 when they joined us. Neither of the operators here is older than 19. Neither of them. So we have these young people joining the project as the ones who are running the system. That's good enough for the general mechanical work, but the machine providers and the technology providers needs to have the eyes over the machine, especially when the work of the machine is not just the drinking water supply. This is the layout of our project. We bring the machine at the heart of a village. We do have connection here. You see the sign of the connection. We have a connection here from the machine and from every operation of the machine. So the machine from one side is delivering drinking water, and from the other side is delivering irrigation water. You again see the signs of sensors here, the signs of communications. So in the farm and in the machine and also in the fish tanks, that the wastewater of the machine goes to, or algae farms goes to fish tanks and sanitation. At every part of this, we have all sensors reading what is happening there. But why do we need so? Why, if the project is in the remotest part of the planet, if the people's need is the absolute basic needs, why do we need to go into the details of technology, into the depth of the technology, bringing a comprehensive remote monitoring? Stay with me for a few slides and then you get the picture. So this is the way that usually the kiosk look like. This one at the top right is one of the remotest islands in East Africa. Here it's right, it's at the middle of nowhere, another remote island in the Indian Ocean between Kenya and Somalia. The other place is all the same. You see the solar panels here. You see the machine at the back. You see the way that they look like. So these machines, although from the mechanical side, it's very simple. Although from the mechanical side, 80% of the maintenance, easily local teenagers, they can manage it. Even from when it comes to the farm, the farming is the drip lines or the vertical farms or the fish farms as well. The simplest of possible way it goes. But from the practical side, we should understand this is the landscape I'm dealing with. This is the landscape my machines are installed. From all the areas around, you see that this one is a village, remote village, right by the Indian Ocean. Somalia is right here. Here is the soil of Kenya, and it's an island. So should I just say I'm installing a machine at the middle of nowhere? This place is exactly the true meaning of the middle of nowhere, the absolute middle of nowhere. So should I just be based, just saying that, okay, I'm installing this machine, is a very simple machine, and then I have no supervision over it, I have no monitoring over it? It doesn't work. If I'm installing the machine, we see the landscape here. This one is in Somalia. You see the landscape is exactly middle of nowhere. And here the challenge is not just even the mechanical simplicity or the being simple. Here we have the challenge of literacy. I come to the literacy issues later. So if a company wants to operate successfully and sustainably in a remote area, in an area that the basics are missing, the simplicity, although simplicity is super important, but simplicity itself is not enough. Locals being able to run the machine is not enough. The project needs another dimension. The project needs another layer. And that layer is when we are dealing with these people. So these are operators. Actually, this one you can see from the logo here is an Oxfam officer. This one is a translator here. Why do we need a translator? These two, as the operators of the machine in Somalia, they are illiterate people. We couldn't communicate with them, and they couldn't really communicate with the machine. We had a translator, two translators to communicate with those who are in charge of operating the machine. But did you see something else here? Did you notice the screen here? We have this screen here on the machine that communicating even with those that they are illiterate, showing the pictures, showing the process, the way that even illiterate people, they can learn it, they can communicate with it, and they can report about it. This is our comprehensive remote monitoring system. So for 24 hours, 7 days a week, we are reading minimum 36 elements, 36 vital elements of water projects running in the remotest part of the world. You see the entire process, from the raw water to the feed part, to the pre-filtration, to the desalination. The position of every valve by color is clear here. You see the valves that are open now, they are green. If they are not open, the valve goes gray. So the temperature, the RPM, actually the operator itself, the illiterate operator, needs just to see what is happening here. If the tank is full, if the tank is half full, then it's orange here. If there is any malfunctioning, if there is any problem, the point would get red here. There would be a red circle around the exact point which is the source of the problem, from the water quality, from the pressure, from the temperature, from hertz, from voltage, whatever. And I'm happy to say it's a nice coincidence that I just speak after Jumo, because the sensors we are using in this system are coming from Jumo, and Jumo is our sensor partner, and I can affirm and I can confirm the quality. Thank you, Jumo, for this service. So then you see here, from one hand, this is our office in Berlin. So the office in Berlin, from one hand, is reading the machine, from the other hand is reading the practice of the machine. The green lines are the time, this showing a month period. The green lines are the time that the machine was functional, means during daytime, and the red lines are the time that the machine was not functional. That's during night time, because this machine is designed for the daytime operation. As I said, there is no battery, there is no diesel engine, there is no grid, nothing. It's just the direct sun radiation. So the interface that is showing here, this interface would be directly available in front of the operator and in Berlin office. Sometime we are improving or programming. We are thinking, okay, we need something to do extra, then we can reprogram the machine right from Berlin. We can switch on, we can switch off the machine right from Berlin. This is the practice that is need to be side by side to the practice of simplicity. If it's just simplicity, many occasions, like this Somalia case, for instance, illiteracy happens, then there is no chance of, even with simplicity, we can hand over the project completely to the locals. So here you can see here, we can see the figures, the temperature, for instance, the frequency, the positions of every valve. Here you see the gray one or the closed one. So in every position, in every order, the positions would be different. If the disinfection units on the flow meters, the position of water in different tanks, the pressure, the TDS, what else? The voltage that is coming from the solar panels. Sometime there might be a shade over the solar panels. I do not need to send a person from Germany to go to the site and finding, oh, a tree has grown here, and then it's putting a shade on the machine. We can simply see it from the remote monitoring. We are reducing the cost of traveling, reducing the number of traveling to the site by just being able to have our eyes on the 36 elements, vital elements of a system operation. There is nothing is hidden from the office here and from the operators in the field. So in practice, we are knowing the system operation better than the operators in the field. I'm sure that some of you may have the question that, did we the one who developed the software for remote monitoring? No, I'm presenting two companies as our partners. As I said, for the sensors, now we are working with Jumo. On the remote monitoring side, this is Weidmuller, another German company who is our partner. For the type of projects now we are doing around the world. So the interface you see here for doing the remote monitoring is the interface that we are using Weidmuller for that service. Just again, explaining to you, so this one is the time that the machine was functional. This one, and the time that machine was not functional is red. This one is the, you see this started from 7 in the AM, now it's 7:50. So this one is a zoom in. is exactly showing in this hour the machine was fully functional. Then you then you see here that when the machine was functional, when was off. So you see here is a weekly basis, 17 days, 24 days, 17th of December, 24th of December, and the rest as well. So it's a matter of zoom in, zoom out on the process of the machine operation. If you want to see it in reality, so here is a machine at the very southeast of Kenya. You see here the interface here, and you see the antennas. You see the two antennas. Every machine having either the antennas indoor or outdoor, depending to the reception. And you see the cables here from the meters, from the valves, from the sensors here, from every part. A cable is going, and you see the bunch of cables here that they go inside the electric box. All those cables are enabling us, reading the process and sending us the signal via these antennas to the site. I want to just show you how our projects look like, plus the position of the machines and position of remote monitoring is there. This is another project. This one is in Mombasa. So again, you see the screen here that is showing all the details. And this screen again is mirroring also as well in Berlin. So we are reading it also in Berlin. And again, the antennas are here for the communication. This one is a very interesting project. This one, in these projects, the previous ones that I showed you, they are communicating in terms of water delivery to people. Okay, if we cannot deliver, people may go and fetch water from another source. But in this project that I showed you, this project is installed in Kenya's second biggest hospital. So by this project, we are delivering water into several thousands of people per day in a special scenario, which is a scenario of hospitals. So you see here in this hospital project, the machine is actually, you may also notice the machine size is much bigger than the previous ones. Again, the remote monitoring here and the antennas there and the sensors are all installed. And actually in this project, because it's a hospital project, because it's a key project, then there are more sensors, there are more functions of the machines that we can monitor, and not just us monitoring. The technical office of the hospital is also monitoring what is happening with this water, what quality of water we are delivering. Doesn't need to wait until people claim the water is saline or so. No, we know it earlier than the operators, then earlier than the clients, earlier than whomever, that if there is anything wrong with the machine. The very same here. This one is actually the other hospital in the same city. So again, you see the positions. And this is the way that is happening during the training. So while we are training operators, this is the same Somalia project that I showed you the picture. So while we are training the operators about the mechanical part, we just travel with them slowly into the remote monitoring, making them sure that what you are seeing here, we can see in Berlin. Anytime we ask anything, just it needs to follow the instruction that is coming from this screen here. Look at this one. This one is our project in Cape Town. So in practice, we are talking about 13,500 kilometer distance from Berlin to Cape Town. The same monitor that was in Cape Town during the installation, the very same monitor is in Berlin. This is our electronic team. So this was the time for the first time that we were doing the remote monitoring with Cape Town. It was the time that we celebrated. So 24 hours, 7 days a week, we are doing that monitoring. So up until this moment, you may say, okay, this company may have 20, 30, 40, 100, 200 machines over the world. Okay, it's possible that I have a few people on the electronic team and they are managing the entire process. Yes, I buy the discussion and I can say that, yes, it can be possible that way. But for a company, when it goes to its scale-up level, when we are talking about several hundreds of the machines, if not thousands, in the coming years, And when we are expanding our water access, not just by simple delivery of water, you see, in this project, let me share with you again. In this project, the operator receives the client, and then operator wash the bottles, fills the bottles, and deliver. In the other projects as well. So you see, there is a filling station. But when we are at the moment of the scale up, the things would not just stop here. Now we have a partnership with an American company. It's called Powerwater. Powerwater is active in Kenya, and as you see here, this is the currency in Kenya, and this is the project. So what Powerwater is doing, Powerwater is reading the remote monitoring of all systems, is reading the sensors of us, is reading the elements of the system operation. And what does it do? People can choose the best water from the closest place to them. So they see that, okay, at this moment, this machine is delivering water at this quality. And they would check if the disinfection is on, if everything is everything in this machine for the water delivery is working perfect, then they order water. They order water by their smartphones, and then these bottles are filled from all systems. So then the delivery service brings them water. So imagine if we have thousands of such water kiosks in different parts of the world. It doesn't work anymore. Absolutely doesn't work that a single office with a few people can manage it. It brings us to the scale up level of our remote monitoring for the sustainability of water sector in a remote part of the planet. So then we are entering into the domain of the Internet of Things. So imagine how many sensors are there, how many readings are happening there. Just easily, it's quickly, we can say if we have 1,000 machine, at every moment 36,000 piece of information is transmitted. Then times to 60 minutes and times to 24 hours. Imagine in one day how much of data we are collecting. To be able to manage it, now we are coming into a partnership with Hitachi, the Japanese giant company for technology, with their product Lumada. So now we are arranging for the practice and piloting of Lumada into our work, to make our work smooth, and to be able to manage in this scale and in the scope of Internet of Things. So then through Lumada, every of our water kiosk and every digits we are reading from the machine is going through the process management, and it's going through the proper management in terms of ordering when things are needed where, and if a malfunction is happening in an area or in a specific kiosk, being able to manage and send the right person to the right place. So this is the next step. We are still now piloting it. It hasn't yet happened, but this is for scale up, and this can be offered to any new markets. For instance, now we are talking about East Asia. I know that Hitachi has a very big office also in Indonesia, in the region, in Singapore. So it can be easily available to be integrated from that office into the prospective water projects we may have in East Asia or in Malaysia and further. So if I want to wrap up my talk, I would say for our work and for all scale up, and for a piece of teachings, for even not us, for all others who want to be in off-grid communities, who want to be in remote places, the key is the technology provider should be able to monitor, should be able to see what is going there. Otherwise, things may happen. People may come with different practices. People may come with different challenges, with different shortcomings. And the challenge happens when you are not able to see the machine. Simplicity is good. Being able to provide an easy solution for people is very good. But being able to monitor what is happening, helping to protecting, first of all, your own cost in terms of traveling, in terms of knowing what the malfunctions might be, and also the important point is giving a self-confidence to your local staff, to your local people, that okay, in case anything happen, There is an I monitoring my work. There is an I supporting my work. There is an I helping me when is needed. This is the beauty of bringing such a solution to such communities and not just leaving them alone. When you leave them alone, I remember it was few years ago, probably 6 years ago, at the beginning of a work, one of the head of the Kenya Water Trust Fund was in Berlin, and he said, you know, you people, you come from Germany, you come from Europe, you come with a with a music player to all villages. He was giving an example. He said, you come with a music player in a village, and what you do is you teach us dance with that music player, and then you say bye and you take the music player with you back to Germany, and then telling us dance. We tell you, look, you took the music player with you. How do we dance? So he was telling us this to tell us we need you to be there, although not physically, but with this remote monitoring, with this capacity, we need you be there. Do not leave us and then tell us operate, tell us do what you should do. No, this doesn't work. Again, the title of my presentation, the title of my speech was the comprehensive remote monitoring to bring sustainability into water solutions in remote part of the planet. And this is the conclusion I have: to be able to bring proper sustainability and longevity to the water projects in the world. We need to have the comprehensive remote monitoring. Otherwise, in a matter of days or months, it comes the moment that no one knows what is happening there, even if the system is simple, even if the operators are well trained. The remote monitoring and detailed remote monitoring is a must. Thank you so much. So I will just stop here. I would like to know if there is any comments, any questions. I'm available for you. Oh, there is a question
Thank you,
here.
Mr. Beheshti, for very nice presentation. Yes, there is. There is a question. I think it's coming from Miss Panita. Would you like to give your question live? You can switch on your video and unmute yourself.
Thank you, Doctor.
My pleasure.
Good. Yeah. Hi, Doctor. I have a question here for you. My question is that how does this product or your system help the authority to make a decision in appropriateness of water distribution when faced with water shortage? Yeah, that's my question.
Okay, thank you for the question, but in general, we ourselves, we are not that close to the authorities because we are super decentralized. But in one place, we are dealing with governments, with authorities, and through that work, what is happening is the government is in Wajir County, north of Kenya, the border with Somalia. In that project, we have 8 water kiosks in one small village, in one small city. It's in a small city, but we have 8 water kiosks all across there. So in that specific place, in that specific project, what we are doing, we are letting them know that where we are delivering water, in case one of the machine needs an overhaul, needs to go through the regular maintenance, they know that the other one should produce more water. And then there is water tracking. So the same software is telling them that in this day the machine is off. In this day the machine is off, and then informing them. It is very simple at the moment. We are talking about one city with 8 systems. But imagine if it's 10 cities, 20 cities with 10 systems per age. This one needs a far more sophisticated and far more comprehensive remote monitoring, letting the operators, letting the authorities know that where do I have water and how much. You know, the trick is in many of these places, water from boreholes. These are boreholes, saline boreholes. These boreholes may face problem with the water volume. Not every borehole is capable of delivering the much of water you need per day. So imagine in one place, the authorities may say that in that place, the borehole is drying now. It happens every day. The water level goes down. They can see that in this place, we will face shortage of water very soon in 4 hours in this place. So they can make sure the other place that the water level is good, that place produce more water, and then delivering to this place or introducing to people that you can fetch water from another 2 kilometers the other side. These are the benefits that at the moment I see in terms of the operation of governmental authorities, the authorities that they are in charge of water.
Thank you, Doctor.
Okay, Dr. Hamid, I have a question. It's with regard to your system. Okay, it's good. I think it's quite relevant to what we're trying to do in Malaysia, especially reaching out to the remote areas and also on the islands. We can talk separately on this, but the question here is, in the market, it shows that this desalination plant is very costly, firstly. Then talk about the maintenance part, it's also very costly. Second, the third point is the source of energy, because it's quite well known that this desalination plant consume a very high energy cost to operate it. So how you tackle that in your projects, especially in the remote area? I know you mentioned about solar, but I'm looking at the lifespans and especially a physical maintenance team that need to be there through the missions.
Thank you so much. Actually, it's the question is in several aspects, but I will just try to go one by one. And the electricity cost, so obviously it's running just on solar and just on solar. So there is just a capital investment, then there is zero cost for electricity, zero cost for power, nothing. So I see your point. The big cost of desalination systems around the world is the cost of electricity, or the fuel to run a diesel engine to produce electricity. So this cost is now zero, absolute zero. There is not even a single cent, it's zero, the cost of electricity and the fuel or whatever. So this is one. Second is the cost of the operation. We are not using chemicals for our treatment. This is a mechanical treatment. When you know that it's a mechanical treatment, then itself is talking to you that when a machine is processed, when a technology is processed, is mechanical treatment, then we do not have the cost, we do not have the regular cost, the high cost of different chemicals to be there to treat water. No, this is the mechanical treatment, doesn't need the chemicals for its desalination process. For the maintenance, for the regular maintenance, yes, we need the acid for the CIP. So these are the regular ones, but this is not a regular cost that you are having it every day, every week, every month. So they are happening once a year or so. And that's not, I mean, the cost is nothing compared to what it's producing. And then it comes to the cost of the machine itself. The cost of the machine, when we are talking about the cost of the machine, you know, always it should be apple to apple comparison. When we are talking about this technology, about the solar water desalination technology, it should be compared to what is the other side of it. So when we are comparing ourselves and our costing in different projects, in different arrangements with all competitors, we simply see that in many cases we are half of the price in the market. In some cases we are 1/4, 1/8 of the price in the market. So we have already proven the affordability of this machine, but affordability is relevant. Affordability does not mean a single family in a village they can buy this machine. No, the cheapest of this machine starts from 20,000 euro. So this is the smallest unit, but the smallest unit is producing 1,000 liters per hour. So as I said, this 1,000 liters per hour is the price tag for the 1,000 liters per hour starts from 20,000 euro. But then when you consider the full package cost plus the delivery of the service you are having from the machine, plus then comparison with what is in the market, then you get to this point of the affordability and the, let's say, lower cost of the solution. Especially it mirrors itself into the production cost of water. The production cost of 50 cents of water for 1,000 liter from direct ocean water is telling you that the system should be cheap. so that the production cost of water is such low.
Okay, very interesting. If you talk about the community just now, what's the largest community that this machine can serve?
Depends to the practice of water consumption. You know, some communities, they consume 100 liter a day a person, some communities just 2.5 liter. But I can speak from the other direction. I can say the biggest machine of us now is producing 20,000 liter per hour. So this is the biggest machine we have produced. And we have limited ourselves to this level as well. We don't want to compete with the giants in the market. There have been huge desalinations in the market for many years. We wanted to fill the gap of small, medium-sized desalination systems.
Okay. Any limitation on the quality of the seawater?
No, it can be direct seawater. Actually, we have even tested it with Red Sea quality, which is super high, is 48,000 ppm. So then it can go to anything lower. We always recommend that since our systems are not too big, get water from a borehole, from a shallow borehole near the ocean. Then the longevity of the system and the cost would be much longer. And the cost.
Agreed. I'm attracted to the IoT part. That's very good. The distance from Berlin to the sites we're talking about 13,000 kilometers just now, you can recall. And how do you tackle the problems of internet access?
Yeah, that's a very relevant question. This service is available when there is a reception, when there is a internet reception. Internet reception means by SIM card. So by anything like 2G, 3G, 4G, whatever, the very basic internet available, then there is a SIM card in the machine, and that SIM card is transmitting the data.
Okay. So can I ask another question? You're talking about machine for desalination, but in Malaysia, we have some remote area that is not near to the sea, but it's looking into the existing source. When I say source, it can either be the groundwater or can be a nearby stream. Because the challenge in supplying water to the remote area is accessibility in terms of their logistic, especially if you look at the geography of Malaysia, say in Sarawak. So it's very far distant. So they are right smack in the area that there's no facilities of energy, but they may have some source of water. Two sources of water you can look at is one is the river and the other one is groundwater. Can that fit in this situation for your machine?
Yeah, easily. Actually, as yourself correctly said, that desalination is not just for the direct seawater. Desalination is wherever there is salinity, and not just salt. Wherever there are minerals, we have projects that there is no salt there, but it's chloride there, it's fluoride there, it's calcium there. So, for instance, the project in Somalia, we do not have salt there, we have calcium there. It's badly contaminated calcium. So, whatever minerals, that is called mineral, is the one that is addressed here. And yeah, it can be river water, but if it's water without mineral problem, sometimes you have a good lake, you have a good river, there is or a borehole, that there is not an issue of the minerals, but it's a matter of turbidity, it's a matter of bacteria, viruses, algae, color. This one, we have a solar water ultrafiltration system. It's a cheaper, smaller, and simpler solution that is for ultrafiltration system. So that one can be also available, but it's a kind of byproduct of our solution.
Okay, that's good. Sounds good. Yeah, I may contact you separately on this because I'm just while talking to you, I'm looking at your brochures. There's one of the slides shows that not the one that you presented in your company brochures talk about 5,000 people drinking water per day.
That one is for one sample water kiosk. It's a sample.
That's a big population, 5,000 can fit in one housing area.
Actually, it's something like a village. Usually, most of the villages we are dealing with, they are anything from 1,000 to 5,000 people.
Okay, all right, good.
Yep.
Thank you.
You're welcome.
Thank you, Dato'. Thank you, Dr. Hamid. Any other questions from the floor? Ladies and gentlemen, my team probably can have a look on Facebook and YouTube Live if we have any other questions. If not, let us thank Dr. Hamid Beheshti for very nice sharing and, on the topic today on comprehensive remote monitoring practice for sustainability of decentralized water solutions. Thank you for a very good discussion. Thank you so much.
Have a great time. I appreciate it.
Thank you. And ladies and gentlemen, we shall move on to our next agenda, and let me share the results of the poll that we have just now. Let me try my best to have a look. Okay. Let me share my screen. I'd like to encourage all of you to please kindly stay because we have a group photo after this with the speakers or participants. So we received 23 responses. Thank you so much for those who have responded. We can see the data there who has responded, and then for the first question on what should technology digital providers do better in, be more cyber secure, integrate solutions better with legacy and other systems, develop a more flexible business model and share risk or reward, and improve ease of use for operational staff and provide more complete end-to-end solution. So mostly agreed with all of the final three solutions: to develop more flexible business model, improve ease of use for staff, and to provide more complete end-to-end solution. And then about 75% agree on for us to be more cyber secure and to integrate solutions better with legacy and other systems. On the next questions, if the impacts and benefits of digitalization in water utilities. Let's see, mostly agreed for allowing real-time event management, for example, for the management of stormwater, NRW, pipe breaks, and etc. And then about 75% agreed on preventing issues and improvement of service reliability and improving the perception of the utility to the mayor and consumer. So we have quite a number of similar agreements here on extending the lifetime of assets and reducing labor costs and reducing non-labor costs. The next question is on the current satisfaction of level of digital usage for the water utilities in Malaysia. Not many, okay, many seems to be disagree in disagreement in terms of adoption of digital technology and the range of technologies provided and the range of solutions, and as well as the impact. And the primary drivers for innovation and transformation within water sector and utilities. So what are they? So most participants agree on resilience, regulatory compliance, quality, efficiency in operations, and then affordability. 75% agree on customer expectation, workforce recruitment, and workforce retention and development. And the final question on where is digitally enabled innovation provide benefits for water utilities and sectors: asset management, customers, human resources, information, water resources. So I'd like to thank everybody for taking part in the survey, and I hope that everyone has had a wonderful time with us throughout the webinar of IR 4.0 for the water subsectors. So before we end, let us invite Yang Berbahagia Engineer Datuk Kadir, Chair Task Force IR 4.0 for water subsectors, to deliver the closing remarks. Please, Datuk.
Thank you, Dr. Nurhaiti. I think taking the positive note from this COVID-19 pandemic situation, it has brought us together today with a larger audience from Malaysia in a very safe environment. And we have covered almost all the topics that we requested. And I would like to say on behalf of Academy of Science Malaysia and Malaysian Water Association to thank the German Water Partnership for their kind cooperation to organize this 3-day seminar, and all the distinguished speakers from well-established German companies whom had contributed their knowledge and expertise on the Water 4.0 Germany experience. Also, special thanks to our Malaysian Embassy in Berlin, Sahafiz, for the kind support to make this webinar successful. For all the participants, I would like to thank you for your attendance, despite of your heavy schedules and our current situation in Malaysia. I hope the Malaysian team has gained on an insight of what is Water 4.0 and have gained, and we can begin our journey towards transformation of our water sector. We hope that the German's company can assist us in future to assist us in achieving our goals, to transform our water sector to be sustainable, and more importantly, to give full access of water and sanitation at an affordable price. That's what being touched upon by the last speakers just now. So thank you again, and I look forward to seeing you in the future events, and I wish you a pleasant weekend and stay safe all the time. Thank you. Back to Dr. Nayati.
Dr. Nayati, you're muted.
Yeah, I think I am on mute. Thank you so much, Dato, for the kind closing remarks, and I believe that marks the end of our 3 days webinar on IR 4.0 for the water subsectors. Herewith, we would like to show our thanks to German Water Partnership led by Ms. Larika and Ms. Julia Browne for attending the session, as well as to all of our secretariat at the Academy of Science Malaysia and the Malaysian Water Association for kind organization of this webinar. I would like to thank all of my secretariat, Panita, Johari, we have Khairi, and we also have Mr. Imran, as well as to our group executive director, Mr. Lee Kunyu. Thank you so much for your kind support and motivation. Ladies and gentlemen, may I invite everyone to please kindly switch on your video for us to take a virtual group photo. I will begin with page 1. Okay, after 3, 1, 2, 3. Okay, and then again, one more. Okay, 1, 2, 3. Thank you so much. We wish you a wonderful weekends ahead, and we shall be in touch with our colleagues at German Water Partnership for future collaborations and discussion. Thank you, Ms. Larika, and thank you, Dr. Salma, for joining us today. Datuk Fateh, thank you so much. Datuk Teo, thank you so much for joining us. Thank you. Assalamualaikum, and have a good weekend ahead. Thank you.
Waalaikumsalam. Selamat Hari Raya.
Bye-bye.
But
Yeah.
thanks, Larika.
Yes,
Thanks, Larika. Yeah, see you.
thank
Bye.
you.
Terima kasih.
Thank you, Mr. Kramer. Terima kasih. Thank you.
Jumpa lagi, Dr.